Hi, welcome back to Core 1. This is Module 4 of the lamination course. And today on this section, we'll be talking about the gel coat and the skin coat in much more detail. Prior to this, we introduced the fibers, the resins, and some of the building materials. Now we're going to start down the path of making a part. And the first step of making a part is putting in the gel coat. So one of the things that we're going to need is we have to have a way to remove the part from the mold. So we need a release agent, and a release agent is used so to make sure the part doesn't stick to the mold. So wax was the most common release agent used in the industry. So the molds are wax, several layers of wax are used on the mold, typically a polyester mold, but molds could be made out of metal also, depending on the industry you're in or other materials. But for boat building, largely you're going to see fiberglass molds. Other release materials came in the 80s, 90s, and now, and there's a whole beautiful range of liquid release agents that can be purchased that work a lot faster and easier than wax and last longer. So it's not necessary to wax the mold with every single part pull. As you'll learn, each part, its geometry, shape, the resins, and the materials will affect how often a tool needs to be re-waxed. So it's not uncommon to get 7 to 10 pulls out of a part before you have to put a release agent on it. With the advent of liquid release agents, some of these mold cycles are extended even further. So another type of release agent is called PVA, polyvinyl acetate. And so this is a material that you'll spray onto the mold, and it actually causes a physical separation. So the PVA will form like a film layer. As the water dries, it's got water in it. You spray it on. As the water dries, it forms a film barrier between the mold and your part. So that'll be pretty much guaranteed you're going to be able to demold. But what that does do is it can cause discoloration of the part due to the effect of the release agent on the mold. So if it's a really cosmetic part, you probably don't want to use PVA. For an industrial part, that might be just fine. Now, when a fiberglass mold is new, the fiberglass still has reactive sites. So it's very common to, if you can, post-cure the mold. That would be heating it up and try and drive all those reactive sites down. The last thing you want to have happen is you try to make a part out of your brand new mold and the part sticks. So we want to avoid that at all costs. So making sure the mold is thoroughly cured, has good layers of release agent on it is a good start. Next, it's very common that after that release agent's put on, we're gonna do what's called a green coat. So for when the mold is first used, we're gonna just spray gel coat in that part and pull it. And this is called seasoning the mold. Okay? So first part, good idea, put gel coat in, peel it out, and then after that, use the second part to go ahead and make your real parts. Okay? And as we discussed, reapplication or release is important. We've got to get it the right time, but if we over apply release, we can get to the other side and we get something called pre-release. So one side of the problem is molds, parts sticking in molds, which is a bad outcome. The other problem is if the part comes out of the mold before we're done laminating. That's another problem called pre-release, which can cause the part to distort. Okay? So as you get experience, you'll learn the different types of molding agents and releases and the different types of chemicals you can use to combat the different situations you're in. So there are mold releases that have different degrees of stickiness so that they can pull harder or easier, because sometimes you need a little more stick to prevent pre-release, like a deck of a boat, which is prone to pre-release. So, well, why do we have gel coat? Well, we talked about it earlier, but gel coat was formulated as the exterior surface of the laminate. For boats, it's the first layer going in the mold. So it gives us our finish. It gives us the durability. It prevents water migration. Okay? And if you remember, the gel coat was formulated to cure as a very thin layer. Okay, and you can see this is a pretty old picture. I bet you that boat's still out there somewhere, because these materials last a long time. That coating could last 30 years. It may fade a little bit, but it will still continue to provide protection. Okay. Also, a gel coat makes it easier to pull the part out of the mold. So if you're not using a mold, if you're not using gel coat and you're just trying to laminate into a mold with the raw resin, you're going to find it's more aggressive on the release, and we'll have to probably wax it or release it much more often than if you're applying gel coat. Protects from the ultraviolet light, okay, because the resin will degrade in the sun. The UV protection is in the gel coat coating. It prevents water from migrating into the laminate. So they bring a lot of value. And you have to remember that the gel coat is the very first step of boat building. We have to get everything right. Any kind of defect or problem in the gel coat is gonna plague that boat and cause rework either in the factory or in the field. So we're going to spend quite a bit of time talking about doing gel coat right because it's so critical. And that starts with the storage of the gel coat. So we want to keep the gel coat in an area that's temperature controlled. Ideally 77 degrees. You don't want to be below 60, 65. Okay. You want it to be at near room temperature, and you want to protect it from fire because these materials are flammable. So by code, you're going to need to protect it. And if you put it under temperature control, you're going to find much better outcome of the result through the material being better stored. Okay. Now, when you buy the material, there'll be a guarantee date, a warranty date. This will typically be 90 days from the date the material was produced. So it's really important as you're bringing new materials into the storage area that you're rotating out your old material. So good material handling systems will take new materials, put them in the back, and they'll push the old materials forward. Because once it gets past that expiration date and the material's not usable anymore, now we have a problem. Now we have hazardous waste that we have to dispose of. And if you think the material was expensive to buy, it costs 2 to 3 times as much to dispose of it as hazardous waste as it did to buy it. So it's really important that we pay attention to our inventory levels and our rotations to make sure we're not generating a lot of waste material that's bad for the environment, bad for business, and bad for profitability. All right, and now the gel coat is not like the resin, so it's got the fillers, the pigments, all the additives in it. And so gel coat sitting in the drum is going to tend to settle. And so the rule of thumb here is that you're going to mix the gel coat for at least 10 minutes every 24 hours. You'll do that with a low speed mixer. You don't want to mix it very fast. If you mix it too fast, you're going to whip air into the gel coat, and that's going to cause porosity on the part. So we want to mix it slowly. You want to mix it for every day you're going to use it. Just got to do 10 minutes. Okay, if you're not going to use it that day, you don't need to mix it. So it should only be mixed when you need to use it. Well, you can only be as good as the mold that you're built in. So the quality of the mold is going to dictate to a large extent the quality of the part. So we need a good quality mold. And the mold needs to be in good shape, needs to not have scratches, dings, anything that's in that mold is going to transmit right to the part. And you'll be surprised how many factories have parts being made from bad molds. All the way down the end of the production line, there's a crew that their job is to not fix the mold, it's to fix every part coming out of the mold. So rather than fix the mold one time, they don't have time, so they fix every single part. Okay, so good shops have good mold maintenance cycles that prevent that from occurring. Okay, so let's start with the mold coming into the shop floor. The mold needs to be at the proper temperature. In particular, in cold climates, bringing a mold in Michigan from the cold minus 40 degree weather into the shop floor is a shock to the mold. That shock can cause the molds to actually crack and the coatings to crack. So you've got to bring them in and get them up to temperature in a controlled manner. Okay, what we don't want is a mold that's cold because we're spraying the gel coat onto the mold, and we're spraying it as a very thin layer. It already has a hard time curing. So if we're sprayed as a thin layer and it's cold, we're going to get bad cure and we're going to get a bad gel coat outcome. Right? We've waxed the mold or released the mold, right? It doesn't have to be waxed, but we've got a nice clean mold and it's got the release on it. Okay? The mold needs to be in good shape, right? If, like we just said, if the mold has bad defects in it, any kind of defects, they're going to be showing up in our part. We don't want that. Right. So here you can see a mold, and the operator is spraying the gel coat in the mold. And you'll notice the body position. Okay, so what we want to be with the gun spraying the gel coat is you want to be 12 to 18 inches from the surface being sprayed. You want to be perpendicular to the part. Okay, we'll go into a lot about the technique and the application. But this is a great picture to get you an idea of what's happening. And now you can kind of see a boat hull with that coating going in. That color you see there is going to be the color of the boat. Okay. So the operator training and the equipment and the materials are all really important. If we get all that right, we have a nice durable gel coat that's going to last 20 to 30 years without any trouble in a marine environment. So let's talk about application gel coat. First step is I got to make sure all my equipment is right. I don't want to stop in the middle of the gel coating process. That's going to be a problem. So I want to make sure I've got the plan in my head. I know what I'm going to do. My equipment is running good. I've got the right amount of materials. I don't have leaks. I'm not going to run out of any component. Okay. We're going to set up the gun. And to do that, we've got to select the correct tip size and the pump setup. Okay. And that's a function of the gel coat's viscosity. We'll go through that in a second here. After the gun is properly set up and working good, we're ready to start spraying the part. And having a plan in your head is very important because what we want to do, this is not like painting. So we want to minimize the triggering of the gun because every time we pull that trigger of the gun, the pumps have to get started and they have to build pressure. And that first half a second or a second, we're off ratio. So we're always going to pull the trigger off of the part and then we're going to come and start spraying onto the part. We call that initial off ratio burst. And then after the gun's sprayed, we're going to spray the perimeter of the part first. Okay, we do that to minimize the amount of overspray and contain most of the materials into the part we're making, not into the shop floor and into everybody's hair. Okay, so if you think about it, the operator holding the gun is dispensing material, and he's determining how thick the gel coat is. And his body motion, the rate at which he moves and how he moves, is going to determine how thick the gel coat is and how consistent. So we're going to show you how to do it nice and consistent here, perpendicular to the mold. And if the operator is moving slowly, we're going to build up the gel coat thicker. If the operator is moving fast, he's going to build up thinner. So those are tools that we're going to use. We're going to keep the gun perpendicular to the mold. We're going to gel coat in multiple passes so that we can make corrections as we do each pass. So we're going to make a pass in one orientation. We're then going to use a mill gauge to check how much material we put on. That's going to calibrate our brain for the next pass. We're going to make another pass on the part in a different orientation. We're going to check the mill gauge again. Now we have one more pass to get it right. So I'll use my body speed for that final pass to speed up or slow down so that I can hit my target millage rate, which is 20 mils, 0.020 mils for most parts. Okay. This technique that we talked about of spraying the perimeter and working towards the inside is actually a formalized technique called controlled spraying. And one of the things that if you're a composite manufacturer, you're dealing with the Environmental Protection Agency. And the emissions coming out of these composites are regulated. And by using controlled spraying, it's been shown to reduce emissions by about 50%. So we want to train to this technique. It's good. It improves the environment. It wastes less material. It's material transfer. We want the material we're spraying in our part, not anywhere else. Okay, so it's a good thing. So controlled spraying starts by setting up the gun right. And the gun is not running by electricity. They run on air pressure. And in the next few series of slides, we'll be getting into the gun and the gun operation. So when you set up the spray gun, you start with the pump pressure at 0. and you're going to start to gradually increase the pressure. And here's a picture of a tip on the right, and you can see there's going to be material starting to come out that tip. It's going to look bad and uneven. At a certain pressure, it develops a nice spray pattern. In this example, it's 50 psi. That'll be different depending on the resin, the viscosity, the temperature, right? Will all affect that. Okay, but now once you've got that pressure, that's it. You've developed the minimum pressure you need to get a good spray pattern. You do not want to go higher than that because then you're going to have a lot of overspray. Okay, so we'll go into controlled spraying, right? Because if we all do things the same way, it's going to make diagnosing problems and the outcome of the product much more consistent. So what we're going to talk about with controlled spraying, we did already, gun setup and calibration. We got to have the gun all ready to go, the proper amount of catalyst, the proper materials. Am I spraying 12 to 18 inches from the part? Am I perpendicular to the part, or am I spraying at an angle? If I spray at an angle, I'm going to get a different thickness from the top to the bottom, for example. Do I have flanges on my tool that are going to contain the overspray? So if you're going for controlled spraying, in the qualification of the part and the employee, they would spray the perimeter. Half of the flange should be dry. The outer perimeter of the flange should be dry. And if you've done that, you've designed a good flange for that part. If not, you may need to make it bigger. Okay, the flanging does not need to be permanent. It can be add-on. It could be plastic sheets. It could be cardboard, anything you want. We're just trying to contain that material. Okay. So we talked about applying in thin layers. We're going to try to do 3 passes in general. We don't want to be a painter. Painters trigger the gun back and forth. We want to pull that trigger, and if we can, we let go and we're done with the part. Minimal triggers. Every time we trigger, we got to go off the part, pull the gun, get it stable, come back onto the flange, get back in the game. Okay, so we want to have that plan in our head. What we're going to do is we're going to have a 50% overlap with each pass, and the passes need to be as big as your ROM. Okay, and if you're going for controlled spraying, you will have documented it. Okay, so here's a mill gauge, and you can see, and this is a little guy. It's got feet cut out, and so when you dip it in, you'll see which feet are wet and dry, and you'll read the gauge, and you'll be able to tell how thick your coating is. Okay, we want to be at about 18 to 22 mils. That gives us the proper gel coat thickness. If we're thicker than that, we're prone to cracking. If we're thinner than that, we're prone to alligatoring and the gel coat distorting and print through, where we see the pattern of the fiberglass through the part. So that's about the sweet spot for gel coat. All right. So some of the problems you may see with gel coat, we just said it, alligatoring, caused by too thin a gel coat. So if you come in at 10 mils or 8 mils thick instead of 20, as that cures, it's going to wrinkle up. And I'll show you pictures of all these things here. Okay. Now, if your gel coat isn't coming out fast enough for the part, the proper answer is to go to a bigger tip. Okay, it's not to increase the pressure of the gun. So the tip size is going to be the first selection in deciding how much resin you want to come out of the gun. If you're making a big part, you'd want a big tip, a whole tip with a big hole in it. And if you're doing a small part, you'd probably want a tip with a smaller hole. It's that simple. Now, if I'm spraying and I'm not perpendicular to the part, I'm spraying on a sharp angle, I can actually separate the gel coat and the fillers and the pigments. All right, so proper spray angle is important for 2 ways. One is it can shear the resin out of it, but also if I'm not perpendicular, the part closest to me, let's say, is thicker and the part furthest away from me is thinner, and I'm getting an uneven coating distribution. As we get into the resin curing technology, you're going to see that resin cures, thicker cures faster than thinner. Okay, so if I have thick areas and thin areas, those are going to cure faster than the thin areas. As they cure, they're going to start shrinking, and I could get a pre-release problem in the gel coat by having just simple uneven gel coat. Okay, we talked about gel coat being too thick. You can get cracking. Okay, print through is when I see the pattern of the chop strand mat through the gel coat. The gel coat should be thick enough that when I put the first layer on the gel coat, the skin coat, which is coming up next, I shouldn't see that pattern in the fiberglass. If I see it, it's either the gel coat wasn't cured properly or the gel coat's too thin. Okay, uneven gel coat causing pre-release. And then next we start to talk about what happens next, because after the gel coat, we've got to reinforce that. And we're going to put chop mat on there. And if we get any air trapped between the gel coat and that matte layer, we have a defect that's going to break out and we've got to repair. So we're going to be really diligent on our skin coat, and that's coming up next on deck. Okay, talked about mixing 10 minutes every 24 hours, but you don't want to over mix, so you want to use big paddle mixers, mix slowly. You don't want to be putting air into the mixing. Okay, you don't want to pump air into your material. So let's look at some of these common defects. See how this wrinkled up? That was a flat film, and because it was thin, it became all wrinkled. It looks alligatoring they call it. Here you can see the pattern of the fiberglass in the gel coat. Okay, here you can see differential areas that had cracking forming, probably due to very thick gel coat. Okay, here you see air entrapment in laminates. Okay, yellowing can be caused in a repair process. If we thin the resin out with styrene, we instead of using patch aid, we can get this kind of discoloring effect, particularly in a repair. Okay, blistering. If we don't get all the air out, or we don't use a good quality resin behind the gel coat, we can get what's called blistering. So water still goes through gel coat at a molecular level. The resin that we use up against the gel coat needs to be a high quality resin. If it's not, that water can attack the gel coat, and then it starts breaking down the resin, and then you get these blisters. These were a big plague in the industry in the 90s, and for a large part we solved that with specialized skin coat resins. We'll talk about that more. Okay, if I'm too late getting onto the laminate, I might not stick to the laminate, in which case I'm going to have a breakout like this where the gel coat did not stick to the subsequent layer. Here's a good example of porosity where air got whipped into the gel coat, and now it's on my part, and I've got porosity. I got a lot of rework to do to get that looking nice. Okay. So summary here. Troubleshooting, if it's too thick, it's really hard. We can't take the gel coat out of the mold once it's there. So if it's really bad and too thick, you might let it cure and peel it out, start over. If it's too thin, on the other hand, we can add more passes and make it thicker as long as it's not cured. Okay, so building up in those 3 steps is a great technique to use. Okay, we want to make sure the gel coat has cured to the right level before we put the laminate onto the gel coat. All right, and there's a tack test. So if you put your finger up on the gel coat, it should not be wet and sticky. No material should come on your finger. It should have just a little bit of tack to it. Okay, and then if the mold had dirt or dust or contaminants, well, we're in trouble because they're showing up in the part. Right. The same thing if our equipment isn't right. If the equipment breaks in the middle of the process, there's a good chance I'm going to have to start over with that. Okay, so having really good equipment, having my work area, the guys trained, really important. Okay, we talked about spray pressure, how important that is to keep the gun running at the minimum pressure for maximum performance. We want just enough air to get a good spray pattern, but not so much that we're creating a resin cloud in the factory and we're wasting all that material and exposing everybody to those chemicals. All right. So some of the other things you might see is if you're noticing that the spray pattern is not good, and you might check the resin pressure and up it a little bit. It could change as you move along with the process, because as you're pulling material from the drum, you're getting to different temperature materials. Okay, for example. All right. If you're starting to see release problems, it's good to tackle those before they turn into a problem that damages your molds. So making sure you've got a range of release materials in your shop, and if you're seeing a release problem, you can pivot to something that's going to be more sticky or more release depending on what's needed. Okay. Keeping track of the cycles a mold is made is going to be important for determining how often you've got to strip the release agent and re-wax or re-release the mold. Okay, you want to keep track of that, because if you're just doing it hodgepodge, chances are you're going to eventually damage your very expensive molds, and that'll really impact your operation. Right, remember we talked about the catalyst, the methyl ethyl ketone peroxide, MEKP. That raw material is very reactive. So if the gun is leaking catalyst, you really want to take care of that. A catalyst leak can start a fire, and you might not have a factory to go to the next day. So before you leave for the night, you always want to make sure all the equipment's turned off, the chemicals are disconnected, be that valves or removal, and make sure everything's in a safe condition so that we all have a good place to come work for tomorrow. Okay. Same thing, we're going to be doing catalyst checks, we're going to do ratio checks, we're going to do measurements to make sure everything's working right. All right, we don't want to experiment on the shop floor in production. We want everything to happen like clockwork. So particular, if there's a new material, a new resin, we'll be doing a lot of testing on it before we release it to the factory floor. Great. Okay, now we've covered the gel coat. We're going to start down the journey on the skin coat. And the skin coat is really nothing more than the first layer of material that we're going to put behind the gel coat. It can be applied either with a chopper gun or as a rolled good. So if we're spraying the material on with a gun, that's called spray up. And if we're laying the chop mat fabric down, that would be called hand layup. And this layer tends to be thin, so we're going to put about 1.5 ounces to 3 ounces of chop, ounces per square foot, onto the gel coat. Okay, and this gives us that structural protection of the gel coat. It's going to protect our structural layers from damage. If we have to repair the boat, we've got this matte layer we can machine and sand into and restore. It helps the matte layers very rich in resin. And that resin richness helps act as a secondary water barrier that's going to help protect our structural laminate from water damage. Okay. Many boat builders, almost all the premium builders, will use a higher quality resin for that skin coat. So they'll either use a pure vinyl ester resin or they'll use a vinyl ester polyester blended resin. The vinyl ester and vinyl ester blend resins are more corrosion resistant. They're less susceptible to attack by chemicals and water. And so we put that right on that first layer. And then after that, we don't worry about blistering because we've got that protective layer. We can switch to lower cost resins in many cases. Okay. So the first step is we want to make sure the gel coat's ready. We've inspected it. It's at the proper cure state. All right. And, you know, just like the gel coat, we had to get it right. If we mess up the skin coat, you're probably going to have damage that you got to fix. Okay. And we'd rather not do that. We'd like the part to come out of the mold and be perfect because it's all brand new material. If I got to start repairing the part, it's going to be on the gel coat side, and my brand new products already got repair, which if you ask the customer, they never want to have that. So giving the guys the right tools is really important. So the gel coat team is going to need to have various rollers because of the geometries they've got. They've got to have small diameter rollers so they can get in there, get the air out, consolidate the fibers. They should all have flashlights on them. They should have brushes. They should have nap rollers. So there should be a good setup of equipment. We'll show you in some other slides some of the tools that we're going to use. Okay. The main thing is before we walk away from the part, we want to do an inspection. So if you got a skin coat team, it's a great idea to designate one of the workers as the skin coat inspectors. Everybody should inspect their work, but we know how it is, right? So the skin coat inspector, before it cures, he or she is going to go around and look for air bubbles or any trouble spots, because while it's still in a liquid state, we can fix that problem really quickly. Okay? If we wait from this point, it's going to get much more expensive. Okay, so at this stage, to roll the air out of the gel coat may only take 1 minute. If we wait to the next step, it's probably going to be a 5 or 10 minute repair. After that, we're not going to be able to get to this air bubble till the part is pulled. Now we're talking about a $1,000 repair. And if somehow that air void gets to the customer, it's in the field, we can be looking at thousands of dollars at the dealership. So it's important to get it right. It can save a lot of grief and save a lot of money. Okay, so we're going to, after we've applied the skin coat, we need to let the skin coat cure, because next we're going to be putting down the bulk lamination, the structural coat. So the gel coat had the right thickness so that the skin coat didn't print through or telegraph. The same thing now, the skin coat has to be cured good enough so that the structural layers don't telegraph through the gel coat. So if you look closely at some boats, particularly old boats, you'll sometimes see the pattern of the structural fibers in the gel coat. Okay, that's what we're trying to avoid here. And we do that by making sure that the laminate's thoroughly cured. And there's a device called a barcode hardness impressor here. And it's basically just a little pin that penetrates into the coating. And the higher the number, the harder the material. And for the particular resin you're using, you're going to have a target barcode reading that's going to say, okay, great, we're cured enough. Now we can go ahead and start the bulk lamination. But before we do that, we want to do an inspection. All right, because if I see any voids now, I can still see an air void between the skin coat and the gel coat. And if I catch it right as the skin coat cures and the laminate's still called green, it's not cured fully. It's hard, but it's not that hard. I can cut that air void out with a box knife, and I can fix it right then and there. Okay, it doesn't take 30 seconds. It takes 2 or 3 minutes, but certainly better than the hours it's going to take later on. So you want to do the inspection. You want to knock down any standing fibers because we're going to put layers on this. If fibers and objects are sticking up, debris, it's going to cause a problem with the subsequent laminations, and we're going to get defects. Okay. So in the world of polyester, we have a neat thing going on called primary bonding. And when you walk into the boat factory, you get that beautiful smell of styrene. And what's going on there is the material doesn't fully cure. It really takes probably a month to fully cure. But in the first few days, there's a lot of bonding going on. And what this lets us do with boat construction is it lets us put that coating in. It lets us put the chop strand mat in. Lets that cure, come in with another layer and next layer, subsequent layers, structure, without having to do sanding and surface preparation, because there's still chemical bonding sites. Okay, and so we want to get our skin coat on our gel coat the same day. If we're waiting to the next day, there's a good chance we're going to lose the part. Now, once the skin coat's on, typically we want to get the bulk lamination on within 2 to 3 days. If we're going to go more than that, we're going to need to sand the skin coat to make sure we have good bonding. So if we waited, let's say we went on vacation for 2 weeks and came back, we definitely would want to sand, because at that point all the chemical sites are gone and we're relying on secondary bonding. Okay. So if we're in a secondary bonding situation, which is, by the way, every repair on a boat, different resins have better secondary bonding. So epoxy and vinyl esters have really good secondary bonding. So if you're doing boat repairs, epoxy and vinyl esters are your choice. You want to avoid the resins that the boat was built with, maybe not the best resin to repair it. So dicyclopentadiene resins, for example, have poor secondary bonding characteristics. They're fine during the construction of the boat, but they're not necessarily the choice you want to have for repairing the boat. All right, that's good. We got some more detail and more coming in the next module.